and you can watch the video if you need to review them one more time. We'll start off with number 7. If I run out of space, I'll just go to the left and right. Yeah, I'll probably run out of space because this is tight over here. All right, so we want to get the radical. This is a radical equation. We want to have the radical by itself, right? Isolate the radical before we can square both sides. So I'm going to add 4 to both sides. So my first step here, I'll write off to the left here, is to add 4 to both sides. So I got radical 2x plus 4 equals 4. And now I can square both sides. So I will square both sides. And now the radical is cleared on the left-hand side, so I get 2x plus 4 is equal to 16. Now the radical is gone, I can try solving for x, so I want to subtract 4 on both sides. So I get 2x is equal to 16 minus 4 is 12, and then I can divide both sides by 2, and I get x is equal to 6. Now we have to check our work, right? Otherwise, we won't know if this is an extraneous solution or not. So check. 2 times 6 plus 4, and then the square root of that, minus 4. Does this equal 0? That's the question. So 12 plus 4 is 16. Square root of 16 minus 4. So that's 4 minus 4 equals 0. Right? So this is a solution. Yay. So hopefully you got that. Let's try the next problem. Number 8, same deal, right? This is the radical here. We have to add the 6 to both sides, right? So we have the square root of 3x plus 3 is equal to 6. And we can square both sides. So we get 3x plus 3 is equal to 36. And then to solve for x, we need to subtract 3. So we get 3x is equal to 36 minus 3 is 33. And then divide by 3 to get x is equal to 11. So now we have to check. So let's check. We have 3 times 11 plus 3, and then the square root of that, minus 6. Does that equal 0? So that is 33 plus 3 is 36. So this is the square root of 36 minus 6. That is 6 minus 6 is equal to 0. So that means this x equals 11 is a solution. Does that work for everyone? Hopefully you got the first 2 questions correct. All right, let's try number 9. Number 9 and 10 are the same, right? So when we subtract 2, we get the square root of 3x minus 2 is equal to negative 2, right? And I hope you remember from Monday's lesson, right? You can't, a square root cannot be a negative, right? It's not real. This is undefined, right? Do you remember how a number squared is always going to be positive, right? So I don't need to continue this any further. This is no solution. Okay, it'd be a waste of time actually to do this. Just remember, a cube root can equal negative, so if this were a cubed root, you would have to continue and solve for x. All right, same goes for number 10. When you subtract 3, you get the square root of 4x plus 1 equals negative 3, right? And the same deal, right? This is a square root cannot be a negative, therefore no solution. Okay? All right, I hope you got those. Let me zoom in over here. let's try the next problem. So 21, we got the square root of x plus 5 is equal to x minus 1. So the radical is already isolated here. So I'm just going to go ahead and square both sides, right? Remember, it's a quantity. You have to square the entire side. So you have to put parentheses around it, right? The radical is already a grouping symbol in itself, so I didn't need to put the parentheses here because grouping symbols means whatever's under the radical would be considered like its own group. It would have like its own set of parentheses that are not written, but it's implied. Okay, so the left-hand side is just x plus 5. The right-hand side is a binomial squared. So if you remember our binomial formula, right? Let me just write this out for those who forgot. A plus b squared is a squared plus 2 times a times b plus b squared, right? And if this were a minus b squared, it would be a squared minus 2ab plus b squared, right? So hopefully you'll remember that to do these binomial squared from chapter 5, right? So this is our first term is x squared minus 2x plus 1, right? And as you can see in these types of problems, we're going to get a quadratic, right? So to solve quadratics, we want to set it equal to 0. So since the x squared is positive on the right-hand side, I'm going to move them to the right-hand side. Right? So I'm going to subtract x and subtract 5. So 0 is equal to x squared, and then you have to subtract x, so this is minus 3x, and then minus 5, right? So that's minus 4. So as you solve this quadratic, you'll see that this is factorable, right? So I get 0 is equal to x minus 4 and x plus 1, right? So practice your factoring, make sure you're really good at it. Now you can set each factor equal to 0 using our 0 factor rule. So you have x minus 4 is equal to 0, x plus 1 is equal to 0, and solve for x. X is equal to 4 or x is equal to negative 1. And last but not least, you have to check, right? One of these or both of these might be extraneous. So we plug it back into the original equation. So we have 4 plus 5, and then the square root of that is equal to 4 minus 1. So that's the square root of 9 is equal to 3. So 3 is equal to 3. That means x equals 4 is the solution. And then I have to check the other one. So we have negative 1 plus 5, and then the square root of that is equal to negative 1 minus 1. And as you can see, the right-hand side is a negative number. So I don't even have to continue. On the left-hand side, I have positive 4 is equal to negative 2. This is already incorrect, right? 2 does not equal negative 2. So x equals negative 1 is not a solution. We have just one solution, which is x is equal to 4. Any questions with that? Hopefully these are starting to make more sense as we progress, right? Let's try the next. So we have the square root of 2x minus 1 is equal to x minus 8. So I'm going to go ahead and square both sides. And the left-hand side, we have 2x minus 1 is equal to, we follow our binomial squared formula, this is x squared minus 16x plus 64. And then the right-hand side, the x squared is positive, so I'm going to bring these terms to the right. I have 0 is equal to x squared, and then subtract 2x, so that's minus 18x. And then we're going to add 1, so that's plus 65. And let's see here, factors of 65. let's see, that's probably, they're both negative, right? So this is 0 is equal to, this is 13 and 5. So x minus 13, x minus 5. That'll do it, right? And we set each factor equal to 0. So we have x minus 13 equals 0, or x minus 5 is equal to 0. So x is equal to 13, or x is equal to 5. Now let me just move over a little bit here. Okay. So we have to check. So let's check. Oh, by the way, is this screen like flickering at all, or is it pretty smooth right now? If anyone can comment on that. I'm using a picture file here, so someone commented. Okay, good. So we have to substitute into the original, make sure that the left-hand side is equal to the right-hand side, right? So this is 26 minus 1 is 25. Square root of 25 is equal to 13 minus 8 is 5. And we have 5 is equal to 5. Very good. So 13 is good. And now we check x equals 5. So 2 times 5 minus 1, the square root of that, is equal to 5 minus 8. So I already see 5 minus 8 is negative 3, right? So I already know this is going to be wrong. Left hand side is 9, square root of 9. 3 does not equal negative 3. So x equals 5, not a solution. Only one solution. X is equal to 13. So you do see the importance of checking, right? You're going to get either one or both can be extraneous, right? Sometimes you'll get none. Sometimes you'll see that both answers are actual solutions. So please check your work, okay?